Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for word search problem. Let's look at the problem description. We are given n by n grid of characters board and an input string word. And we have to return true if that word is present in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same cell cannot be used more than once while we are checking the board. Okay, so let's take a look at the example 1. So we have a 3 by 4 grid and the input word is A, B, C, C, E, D. The letters A, B, C are located in the cells which are horizontally neighbors, and C, C, E are located in the cell which is vertically neighbors, and E, D are located in the cell which are horizontally neighbors. So that's why we can find that word that satisfies the neighboring property. So the output is true. So in the case of example 2, so the input word is SEE. So the S and E are neighbors vertically and E and E are neighbors horizontally. So this word can be located in the grid that satisfies the neighboring property. And in the case of example 3, we have the word A, B, C, B. A, B, C, B. Okay, but the second condition is we cannot use the cell which is already visited. Okay, so in this case first we visited A, then B and then C, and just because B is neighbor horizontally, we cannot declare that the word A, B, C, B is present. Okay, because we cannot use the cell which is already visited. This cell is already visited, and the other neighbors which are horizontally and vertically present are C and E are the other neighbors, which is not equal to B. So the output is false. The constraints for this problem are M is the length of the board, the number of rows, N is the number of columns, and the value of M and N will be ranging from 1 to 6, and the length of the input word is ranging from 1 to 15. The board and word consists of only lower and uppercase English letters. Let's look at the approach to solve this problem. We are given this input board 3 by 4 grid, and the input word is A, B, F, D, E, G, C. Okay, so in this case the letters A, B are horizontally neighbor, B, F, D are vertically neighbor, D is horizontally neighbor cells, and E, G, C are vertically neighbor cells. Okay, so we can find the word in the cells that are adjacent horizontally and vertically. In the case 2, the input word is A, B, F, D, E, G, F. Okay, so A, B are horizontally neighbors, and B, F, D are vertically neighbors, D, E are horizontally neighbor, E, G is vertically neighbor. Okay, and the last letter F, even though F is a neighbor, but one of the rules states that we cannot use the cell which is already visited. So in this case we have started from here, visited all these cells. Okay, and this cell is already visited. So even though it is a horizontally neighbor cell, we cannot visit that cell again, and also no other neighbor cells have the value F. That's why we cannot find this word in this grid. That's why the output is false. At each cell there are 4 possible neighbors. Okay, for example, in the case cell with the letters G, the neighbors are in the row above the current cell, row below the current cell, and cell which is located in the previous column, and the 4th neighbor is located in the next column. Okay, so these are all the 4 possible neighbor cells. So in order to satisfy the condition of not visiting the cell which is already visited, what we can do is, as we traverse these cells, we can mark each cell as visited until we reach the end of the word, or we reach the cell which is at the edge of the board and also the surrounding neighbors are all already visited. For example, in this case, so we start from the cell A, mark A as visited, then B as visited, and F as visited, and then D as visited, and E as visited, and right now we are at G. Okay, and the next character is F. So when we look at it, the F is not present. By doing this, we can satisfy that second rule. We will never visit the cell which is already visited in the search path. For each cell as we visited, we mark it as visited already, and then we try to locate the next letter in the neighboring cells. We repeat this until either we find all the letters in the input word are found, or we visited all the cells in the board. So basically we can solve this problem using recursion with backtracking. Whenever we see neighbor characters are not matching, we can return because no further search is required in that path. In that case, we can backtrack and then find an alternate path to find the input word. So that's what I have written here. Basically, we can solve this problem using recursion with the backtracking. First, we initialize the number of rows and columns and then initialize the index to 0. Next, we traverse each cells in the board. Whenever we find the first cell which matches the first letter in the input word, we call the search function with the row and column index of the current cell and then the index of the first character in the word. Inside the search function, we check whether the index is equal to the length of the word. That means we found all the characters in the input word in the grid. So we return true. This is the base case. Next, we check whether the row and column indexes are out of bound. In that case, we return false. We are backtracking. And then we check the value of the current cell is not matching with the character at the current index in the word. In that case also we backtrack. Otherwise, we save the value in the current cell in a temporary variable and then we mark the current cell as visited. Okay. Basically, we set value 1 in that cell. Okay. Then we visit all the neighbors of the current cell and make a recursive function call with the row and column index of the current neighbor and index plus 1. Basically, we look in the next call, we try to find the match for the character located at index plus 1 in the word. If the search function returns true, that means we found the word. So we return from the search function. Once we return from the search function, return true as the output. Otherwise, we'll try to traverse all the cells in the grid. At the end, we return false. Let's look at the flowchart. Input for this exist function is grid board and then the input string word. First we initialize the rows and columns and the found boolean and the first character variables. Found will be initialized with false. The first character will be initialized with the first letter of the input word. And then we initialize the index I. And here in this nested for loop, we traverse all the cells in the input grid. And if the value of the current cell is equal to the first character, then we start the search from that cell, okay, by calling the search function with the row and column index of the current cell and the board and the word and then index 0, which is the first character in the input word. After returning from this function, we assign the return value to the found boolean and then we check whether the found is true. If it is true, if the return value is true, then we return from this function and return the true as the output. Otherwise, we try to find the next cell that matches the first letter in the input word and then initiate another search. We repeat this until we visit all the cells or we located that word in the grid. Input for the search function is the start row index Si, start column index Sj, and then the board and the input word, and then the index of the character that we are trying to match. Okay. First we initialize the rows and columns and the found variables. The found is initialized with false. Next we check whether the index is equal to the length of the input word. That means we found the word in the grid, so we return true. Otherwise we check whether the row index and column indexes are out of bound or character in the current cell doesn't match with the character at index in the input word. In that case we return false. Basically we are backtracking. Otherwise we save the value of the current cell located at row index Si and Sj in the current cell variable, and then we mark the current cell as visited by setting the value 1. This is to prevent visiting the cell which is already visited in the search path. Next we enter this for loop to traverse all the neighbors of the current cell. So for each neighbor we call the search function recursively with the neighbors row index and column index and the board and the word input word index plus 1. Basically we try to find the cell which matches the character at index idx plus 1 in the word. Then we assign the return value to the found boolean, and then we check whether the return value is true. In that case we return from this function. Otherwise we try to process the next neighbors. Okay. Finally we restore the value in the current cell, and finally we return the found boolean. Let's move on to coding. First I define a constant visited with a value 1. Next I implement the exist function. First I initialize the found variable to false, and then initialize the number of rows and number of columns, and then I initialize the first character variable. This will contain the value of the first letter in the input word, and then I write the nested for loop to traverse all the cells in the grid. So whenever the current cell's value is equal to the first character variable, then I initiate the search by calling the search function. The search function will take the row index and column index of the current cell, and then the board and the input word, and then index 0. Then I check whether the return value is true. In that case, since the word is found, I return from this function. If that word doesn't exist in the grid, then finally I return false. Next I implement the search function. First I initialize the found boolean to false, and then I initialize the rows and columns. Next I check whether the index is equal to the length of the word. This means that we found word in the grid, so we return true. This is the base case. Next I check whether the current row index and column indexes are out of bound, or the current cell's value doesn't match the character at index idx in the input word. In this case I return false because we do not have to compute the rest of the solution because the character doesn't match, so there is no value in continuing that path, so we backtrack. Hence I return false. Next I save the current cell's value in the variable current cell, and then I mark the current cell as visited. Next I define a distance slice. This is a slice of int. This contains the offset between the current cell and its neighbor. So the first one is for the neighbor located in the row above the current cell. The second one is below the current cell. Third one is located in the previous column. The last one is located in the next column. And I write the for loop to traverse this distance slice. Each iteration I compute the neighbor cell's index value. Then I make a recursive call to search the next character in the input word. So if the return value is true, I break out of this loop and return the value true back to the caller. After coming out of the loop, I restore the value in the current cell, and then I finally return the found boolean. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given a 3x4 grid, and the input word is BCG. Okay, and so BCG, B and C are horizontally neighbors, and CG are vertically neighbors. So we can locate the word BCG in this grid. So the output is true. First we initialize the found boolean and the row and columns and the first character variables. Okay. So here the rows is 3 and columns 4, and the first character is B. And then found is initialized with false and the index is 0. Then we enter this nested for loop. For simplicity, I just directly go to the cell which has the first character of the input word. In the outer loop iteration 0 and in the inner loop iteration 1, we can locate the cell which has the first character of the input word. Okay. So in this case, I is equal to 0 and j is equal to 1, and the found is initialized with false. Then we initiate this search by calling the search function with the current indexes. Okay. So in the search function, first we initialize the found boolean to false and the rows and columns variable. Then we check whether the index is equal to the length of the word. In this case, the index is 0, so this condition is false. And then we check whether the row and column indexes are out of bound. In this case, 0 and 1 are within boundary of this grid. And then we check whether the current cell's value doesn't match the letter at index IDX in the word. In this case, B and B are matching, so this condition is also false. Next we save the value of current cell in the current cell variable. So the B is assigned to the current cell, and then we mark that current cell as visited by setting value 1. So it changed from B to 1. So next, the neighbors of the cell B are F, A, C. Okay. So for simplicity, I am just picking the neighbor which matches the next character. So in this case, C. Okay. So here we make a recursive call to process that neighbor. We pass the neighbor's row and column index, which is 0 and 2. Again, we check whether the index is equal to the length of the word, and then whether the row index and column indexes are out of bound and the character is not matching with the word with the letter at index IDX. So this condition is also false. Then we go ahead and save the current cell's value in the current cell variable, and then we mark the current cell as visited. So the C is marked as visited and the current cell value is assigned to the current cell variable. Okay. Then we make another recursive call to find any neighbor which has the letter G. Okay. So I pick up the cell which has the value G. Okay. So in this case, the cell at row index 1 and column index 2 has the letter G. So again, we check whether the index is equal to the length of the word. In this case, it is not. And then we save the current cell's value and we mark that cell as visited. Then so the G is saved in the current cell variable, and then we mark that cell as visited. So this cell is marked as visited, and then we make another recursive call, and in that call we check whether the index is equal to the length of the word. So in this base case is true, so we return true. So when we return from this function, the found value will be set to true. So we break out of this loop and return from this function, and we return all the way back to the exist function. So in the exist function, if the return value is true, then finally we return true as the output. That is an expected output. Next, I am going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of m times n times 3 to the power l, where m is the number of rows and then n is the number of columns, l is the length of the input word. Okay, so in order to find whether the given input word is present in the grid, in the worst case we have to traverse all the cells in the grid, which is m times n number of cells. Okay, and at each cell we have 3 options to move to the next cell. Okay, because we cannot go back to the cell from which we entered the current cell. Okay, so that's why at each cell we have 3 options to go to the next neighbor. For each character, the number of times we make a recursive call triples. Okay, for example, when we match the first character, after matching the first character, we have we need to make 3 recursive calls to find whether the next character in the input word matches. And for the to check whether the second character in the word matches, we need to make the 3 times 3, 9 recursive calls. And for to match the third character, we have to make a 9 times 3 recursive call, which is 3 to the power 3. So to match the nth character, we have to make 3 to the power n recursive call in the worst case. So, and for there are totally m times n number of cells. So the time complexity is order of m times n times 3 to the power n. The space complexity is order of L because the recursive function uses the stack space. The maximum height of the call stack is the length of the input word. So for each character we make 1 recursive call. So that's why the height of the call stack is L. So the space complexity is order of L. Thanks for watching this video. Have a great day.